Alright, so today we're going to talk about finding exact values for angles that aren't on the axes. So specifically angles that aren't multiples of 90. And so if you look at this first one, it says I've got the cosine of 30. And so my task here is going to be to find the exact value of the cosine of 30. And so what I'm going to need to do now is I'm going to go ahead and draw an angle in standard position that has a measure of 30 degrees. And so first of all, drawing an angle in standard position, remember I'm going to go ahead and start with the axes. 30 degrees is in quadrant 1. So what I'm going to now do is I'm going to go up 30 degrees. And so this is 30 degrees. Now if you remember, what is always the distance of a point from the origin? It's always going to be 1. So that means that's what my hypotenuse is going to be. And so now, this is my reference angle of 30 degrees. Okay, what I need to do, remember, is draw my side down so I've created a right angle, in which case this up here is 60 degrees. The last thing I need to do in this triangle is I need to label sides. So we know a 30, 60, 90 triangle has special relationship between the sides. And so if my hypotenuse is 1, can somebody tell me what the length of one of the sides is?
2.
No.
Yeah, 0.5, right. Kale, what'd you say? Which one is 1/2?
The shorter one.
The shorter one is 1/2, the side opposite 30. So the side opposite 30 is always half the hypotenuse, which in this case is half of 1. Does anybody now remember what this side will be?
Root 1/2.
Root 3 over 2. Remember, it is root 3 times your shortest side. So root 3 times 1/2. So those are the sides. So now what I need to do is look in that triangle and see what the cosine of that is. So in looking at this triangle, I know cosine is what over what? Cosine is adjacent over hypotenuse. Okay? Cosine is adjacent over hypotenuse, so in this problem, my adjacent side is root 3 over 2. My hypotenuse is 1. So cosine of 30 on your chart should be root 3 over 2. If I were you, I would have that pink chart out with you, filling it out, as well as in your notes.
30.
So cosine of 30 is root 3 over 2. So just for kicks.
So 2 root 3 over 3.
So, yeah, so just for kicks, let's figure out what the sine of 30 is going to be. The sine of 30 is going to be opposite over hypotenuse. So in this triangle, what's the opposite over hypotenuse going to be? 1/2 over 1, which is just 1/2. Now, the nice thing about these triangles is that you really don't even need to worry about the hypotenuse. Because since the hypotenuse is 1, it's going to be whatever the side is. And so then I can find tangent. Tangent is going to be opposite over adjacent. So tangent is going to be 1/2 divided by root 3 over 2. The beauty of this problem is that the 2's cancel. And you end up having 1 divided by root 3, which you know is not acceptable. And so as somebody has already said, the answer is root 3 over 3. Very good.
So then would the opposite of that just be root 3?
Yes. And if you didn't catch that, what was just asked is if the cotangent of 30 would just be root 3. And that's why it's nice to have this one written, because if you flip that one, you then get root 3 as your answer. Okay? All right, let's look at another one. Sine of 240. Sine of 240. So, like I said, if I were you, I would still be writing some of these down in your notes, because you can use your notes on your quizzes. And so, sine of 240. What quadrant? Third. So I'm going to make that quadrant just a hair bigger than everything else. Okay, 240 means I'm going to go this far around, and here's going to be my triangle. So to make my reference angle, which way do I draw? Vertical. Always draw up. And there I've created my right angle. So now what I need to do is find this angle right here. What's,
40 minus 20.
which is 60. Now, for those of you wondering where that came from, the whole entire angle was 240. I know that this angle here is 180. So the difference between the two is 60. Just a little tidbit, everything on your pink sheet will either be a multiple of 90, 30, or 45. So it is going to be a special triangle. So now, I know my hypotenuse is always what? 1. So let's start filling in sides. Ideas. What are some of the sides going to be?
1/2
Where's the 1/2 going to be?
at the top.
The 1/2 is going to be here. Now, one of the things to keep in mind, this is actually a negative 1/2. Because remember, sine, cosine are both negative in quadrant 3. What's your vertical line going to be? Root 3 over 2. So negative root 3 over 2.
Why is it just because
So
of
this thing?
It's a 30, 60, 90 triangle. And it's and this is the thing with the negatives. You can look at where it's located. Okay, it's located to the left, which is negative, and down, which is negative.
So what if
So-
it's rotated to the left? Up.
Then this side would be negative, that side would be positive.
So it's really not vertical.
No. What's the sign going to be there?
Sign.
Um,
Negative
negative
2.
Negative root 3 over 2. There you go, there's the sign. Okay? So sine of 240 is negative root 3 over 2. So for kicks,
so -2 is the
what's the cosine of 240?
Negative 1/2.
Negative 1/2. Okay, so you kind of get the hang of things?
No. Oh yeah,
Is it, wait, cosine is with,
You made these backwards.
Sorry.
It's confusing. It's
So
okay.
here we go, cosine, 3 pi over 4. So 3 pi over 4. Where's that going to be at, folks?
Well, it's negative 135 degrees, so it would be in quadrant 3.
Cosine of 3 pi over 4. Not negative, 3 pi over 4. Quadrant 2.
I don't know.
Now, this is the thing. Once again, we could be thinking about fractions if we wanted. We know that 3/4 lies between a half and 1, so that would also put it in quadrant 2. So now I need to figure out what is my reference angle. So remember, to form my reference angle, I'm going to draw a vertical line. And I've got to find what that missing angle is. And that missing angle is pi over 4, or 45 degrees. What's the hypotenuse going to be? 1, because it's always 1. Now I need to figure out what the sides are going to be. Does anybody remember what the sides are?
The same. 1/2.
They are the same. Not 1/2,
Root
close.
2.
It's a combination of root 2 and 1/2. It's actually going to be root 2 over 2. Now, come test time, if you have a total brain lapse and you forget, there is a way to do the 45, 45, 90s. And what you would do is just a squared plus a squared equals 1 squared. Because you know the sides are the same in a 45, 45, 90. So I just chose to go ahead and use a squared. So this I get 2a squared equals 1. If you go ahead and divide by 2, you get a squared to equal 1/2. Next step is to undo a square, which is the square root. So what I'm going to go ahead and do is take the plus or minus square roots. And so a equals, in this case, 1 over root 2, which simplifies to be root 2 over 2.
The one's negative.
Now 1 is negative. Which one is negative?
Bottom one.
The bottom one is negative, and basically all you're doing is you're looking at your location to determine if it's positive or negative. You know, from the origin, a negative number is to the left, positive number is up. So in looking at that triangle, what is the cosine in that triangle? What is the cosine?
Negative root 2 over 2.
Negative root 2 over 2, because remember, cosine in this triangle is just your adjacent side over the hypotenuse. Your adjacent side is right here, which is negative root 2 over 2 divided by 1. So what's the sine in that triangle?
Root 2 over 2.
Root 2 over 2. What's the tangent?
Root 2 over root 2. So negative 1.
It's negative 1. Yes, because they're the same. Okay. Tangent is opposite over adjacent. Those are both the same. The only thing different is the negative. All right, so
So
far
then
so
the
good.
opposite of tangent would be negative 1.
That's 2 negative 1s.
Okay, so, you think we need to look at another one, or do you think you kind of got the hang of things?
I think we should do about 4 or 5 more.
I've got actually another problem after
I
this.
don't
that's
know
what I was
what
wondering.
I did for.
Do we need to look at this secant, or you think you got it?
Got it.
We already did that one. Kind of.
Yeah, so we don't care.
So let's go ahead and look at this one. Find the exact values of the 5 remaining trig functions of theta. This is where that little chart that I had you write down in your notes yesterday is going to come in handy. Remember I had you write sine, cosine, tangent in each of the quadrants, and you wrote like plus, minus, plus, minus? That's where this is going to come in handy. It says find the exact values. So that means no decimals. Exact values are fractions only. Of the 5 remaining trig functions of theta. And so what I'm going to do while you guys are writing that down, I'm going to go ahead and make my little answer key to make sure that I leave nothing out. And by doing this, you're going to see that there is one answer you could answer right away from the beginning. So now, when you go through and do this, you should be able to get one right away. So there should be no excuse that nobody can't get any points right on this one.
Secant.
What do you already know? Secant is root 3, so what does that tell you? Cosine is
Root 3 over 3.
1 over root 3, but you know that won't fly. So 3 root 3.
Well, it would fly.
Oh, wait, I wrote that wrong. Just a second. I wrote it wrong. Let's change it. It's going to be root 3 over 3. So there you go. So now what I need to do is I need to go back to my nice little positive negative chart. You should all have that. Okay, your nice little positive negative chart. On that, I want to know in what 2 quadrants is cosine positive. So right now I'm looking at this fact right here. Cosine is positive.
1 and 4.
So in quadrants 1 and 4, cosine is positive.
Is this important?
Yep. So in quadrants 1 and 4, cosine is positive. So that basically means that I'm only looking at those 2. Now the question is then, where do I draw the triangle? Do I draw the triangle in quadrant 1? Or do I draw it in quadrant 4?
We have to wait until we find out.
What class? Oh, for math, yeah. Okay, so I've got quadrant 1 and 4, so now I need to decide, do I draw my triangle in 1 or 4? And so I've already utilized this piece of information. Now I need to utilize this piece of information. Okay, tangent is less than 0. What does that mean?
It's got to be below.
It means that tangent is negative. So this means where is tangent negative? And so the beauty of this is, if I look at these, there's only one of these quadrants where tangent is negative. Where is tangent negative?
4 because
Quadrant
1's
4.
all positive.
1 is all positive. Everything's hunky-dory there. So here's where I draw my triangle. Okay. Now what I need to do is label sides. Okay, they tell me that secant is root 3, which cosine then was 1 divided by root 3. And so when I think about cosine, theta was 1 divided by root 3. Cosine is adjacent over what, folks? Hypotenuse. And so that tells me that 1 is my adjacent side. That tells me that root 3 is my hypotenuse.
So then it's the.
So then what I need to do now is find what is my opposite side. So how can I do that? Pythagorean theorem. Pythagorean theorem states 1 squared plus, we'll call that a squared equals root 3 squared.
Like, can we not do a 36
Hmm?
We don't know if it's 36.
It's not going to be that. The question is this a 30, 60, 90 with the root 3? No, it's not. And you'll see that shortly. So I end up getting 1 plus a squared equals 3. Sorry, I forgot the squared there. So what does a squared equal? 2. So what does a equal? Root 2. So that means this is going to be root 2. Now, one other thing to notice, that's actually a negative root 2 from its location
Oh, wait, how do we know that?
because of where it's located down.
Is it root 3 too?
No, your hypotenuse is never negative.
Okay.
Hypotenuse is always positive. That's just kind of one of those little things. So now sine in that triangle is going to be what, folks?
I thought our hypotenuse was always 1.
When you're finding exact values, this is different, this is a different. So now sine is going to be what over what?
That says.
It's negative.
Yep. Negative root 2 over root 3. So we got to simplify that. So let's simplify it. Root 3 over root 3. What's it come out to be? Negative root 6 over 3. Good. So the cosecant. What's the cosecant going to be?
3 root 6 over 6. Negative 2 root 6 over 6.
So negative root 6 over 2. And then last but not least, tangent.
It'd probably be negative 6 over root 3, which would be
Okay, let's look at your triangle first before you do all that work. Opposite over adjacent. What do you get? Negative root 2 over 1, which is just negative root 2.
Oh my
Okay.
gosh.
So then what's cotangent?
Negative over 2.
Negative root 2 over 2. Alrighty, let's look at another one of those, just to make sure we've got it down. Okay, find the exact values of the 5 remaining trig functions of theta. Now this one's going to be a little nicer because it's not going to have 2 roots. We did the tougher one to start with. Okay, so if I were you writing this down, I'd just put sine theta equals 5/7. Cotangent theta is greater than 0. And then I'm going to make my nice little sine theta equals, cosine theta equals, tan theta equals. And so I already know that sine is 5/7.
So 7 fifths.
So obviously we get 1 right, as you said, 7/5. And so remember, I start, very first place I start is I start looking here, sine of theta equals 5/7.
1 and 2.
And so I look at my chart and I say, oh, well sine is positive in quadrants 1 and 2.
But you don't want the bottom one because it says that code.
So now, cotangent is greater than 0. Cotangent goes with what, folks?
Tangent.
Tangent. So I want to know, where is tangent positive?
The bottom quadrant.
So I'm only in 1 and 2.
yeah.
Quadrant 1, good. So now everything's in quadrant 1.
Wait, why not 3?
Because we originally started with 1 and 2 because that's where sine is positive. You start with sine first. Sine limited it to 1 and 2, and based on those last 2, I'm in quadrant 1. So what does that tell me? Sine being 5/7?
That the opposite is
Opposite is 5. What's the
7.
7? Good. So now all we need to find is what?
Adjacent.
Adjacent. So 5 squared plus a squared equals 7 squared. We're just about done. So hang on. So I end up getting 25 plus a squared equals 49.
That's where it's going.
A squared equals 24. So a equals root 24, but once again, you know that won't fly. What does that come out to be?
Four root six.
2 root 6? Yep.
Yeah.
Okay, because you needed to only take out one of the twos. If you broke it down.
2 root 6. So what's the cosine in that triangle? 2 root 6 over 7. Tangent is going to end up being 5 over 2 root 6, which actually is going to be 5 root 6 over 12. Cotangent is going to be the flip of that, which is 2 root 6 over 5. For those of you wondering, that's why I wrote this down, is because it's easier to flip that. And then secant is going to be 7 over 2 root 6, which is
6 over 12.
7 root 6 over 12. Good. So there you go. So we've got exact values of single functions, and we've got these exact values. So what you need to do is finish 12 through 58, the evens. Okay, probably going to have a quiz Monday or Tuesday-ish.
I love being quizzed.
All right.
Test my knowledge overall.